Hi, I'm Jeremy Kirk with Intel 471, and this is Happy Hunting, our guide to threat hunting in your logging systems. With me today is Lee Arkinall, who's a senior threat hunt analyst. How are you, Lee?
Doing great, Jeremy.
Lee is going to soon demo a threat hunt, but I'm going to give you some background on what this threat hunt is designed to find. It involves an initial access broker who goes by several nicknames. One is Miyako, one is Mia, one is Mame, and there's several others. We're just going to refer to this person as Miyako. So just a bit of background on initial access brokering. These people are often referred to as IABs, and they basically sell access to compromised systems or networks. Because obtaining access to systems or networks is a very time-consuming process, threat actors have developed this into its own cybercriminal category. So you can go on various markets or forums and engage other actors who've secured access either through stolen login credentials, or they've actually used software vulnerabilities and developed exploits and gained access. Sometimes the access will be proved, so they'll show, like, say, a screenshot of Windows domain controllers to prove that they actually have that access. And basically, by buying this access, then that leaves the other threat actors downstream to just go ahead and deploy malware or steal data or move on to other types of attacks such as extortion or ransomware. So Miyako is particularly known since last year due to this actor's pretty sophisticated tactics, techniques, and procedures. The actor claims to work alone, but the person has been involved in a series of high-profile breaches that's focused on data exfiltration and exploiting high-value targets. These targets have been in government sectors, telecommunication sectors, critical infrastructure providers, and Miyako was a very active persona on breach forums, which was one of the very well-trafficked cybercriminal forums. And this person was also kind of a member of the Hellcat hacking group as well. So earlier this year, in January 2025, Miyako wrote a guide to exploiting organizations. And so this basically outlined this person's methodologies for conducting intrusions, maintaining persistence, expanding into footholds, and monetizing that compromised access. So this guide kind of allowed other threat actors who sort of aspired to be access brokers or wanted to learn how to gain access to systems, basically like a step-by-step guide. And so Miyako wrote about the tools that they used, the command that they would use to basically perform the same attacks. And so Miyako discussed finding proof of concept code, testing that code, looking for new CVEs to potentially exploit, and also using internet-wide scanners like Shodan and Census to find potentially vulnerable servers. So this guide covered exploitation of several enterprise products that have had issues, such as F5's Big IP, Advanced Firewall Manager, Palo Alto Networks, PAN-OS, a lot of these edge devices that are frequently attacked. And like I said, it also provided suggestions for how to sell and monetize this access. So if you're interested in more insights about Miyako and this whole IAB economy, we have many intelligence reports in our Verity platform that you can go and look up. So with that, I'm going to turn it over to Lee now, who's going to discuss how to detect some of the techniques that Miyako uses and are discussed in the guide. So Lee, take it away.
Thank you as always, Jeremy, for that wonderful intel. But let's now talk about how we can make that intel actionable. So what are we looking at? And that's why we like to focus on TTPs and behaviors that all of you may be accustomed to and hearing from us. But adversaries abuse living off the land binaries or LOLBins like PowerShell is nothing new. In this case, the actor Miyako abused PowerShell to download their malicious payload from their attacker-controlled domain. Now, if we take a look at what that looks like in practice, we can see the artifacts that we can look for. So let's take a look. So we're going to use this hunt package, methods for downloading files with PowerShell, to look for behaviors associated with actors like Miyako. First off, to get our heads wrapped around what it is, we can look at the description. This is where the hunt package is designed to identify instances where PowerShell is being used to download files from external sources, which, as noted, is a common technique used in malware delivery and lateral movements. But what does that look like? If we come down to the base logic, we can see the key value pairs that we'll be looking for, or the field value value relationships. We got the process paths. We're looking at process command lines. You can see we're really focused on PowerShell over here. But then after that, we're looking for any other command that allows adversaries or legitimate users to download different files. Now, what that file does is really like the intent of it and how you can tell what's going to happen. Or not that you can always tell, but if it's a legitimate admin downloading tools for your environment that are legitimate to be used legitimately, you might find that along the way. But if you see an adversary reaching out to a randomly named domain, that might stick out as well. In this example, we can take a look at Miyako's actual command that was reported, and we can see that they used PowerShell, and then in there we can find there was an invoke web request. Then we can see that they reached out to their attacker control domain and downloaded their malicious payload. Now this is just an example. It's not exactly what was shown, but it shows you the syntax of the command, how it's built, and makes it easier to understand. And then you can see that it's actually being targeted to land in the Windows temp directory, which is a type of directory that is obscure and that legitimate people aren't going to be looking at from day to day. So it's an easy place to hide. Then if you continue down, you can see that they started the process right after it made. Now, if you take some time in this hunt package, you can see that there are actually many more groups or malware that use this behavior. Right under here, you can see that SafePay ransomware was seen using PowerShell's web client to download a file. So it's not just this actor, this one actor. This is actually a very common behavior that is abused by different actors, which gives you a wider net so that you're tossing at your data. So you're not just returning a specific threat. You can look at a bunch of threats at one time. And if we take a look at what that really means in the data, we can use the query itself. Here, we're using our Splunk, which is our SIM that we're using for today. You can notice that the query logic itself is built just like the base logic was. Yeah, we transform some things because we can manipulate the data here in Splunk, but it all boils down to the same thing. We're looking for the same values living in the same fields. And what you get is a result where you can take a look and aggregate the data in a way that allows you to see more artifacts and hunt for those moving forward. So you can see here that it was first seen and last seen on the same day, so you can tell it was only run once on this host. You can see the process was actually PowerShell.exe. The parent process was PowerShell, but then we have the command line arguments, and this is where you're really going to get the meat of the data. So you can see that we reached out to this google.com for a PNG file, and you can see all the artifacts that exist. Now, I'm not saying this is exactly what you'll see in your environment, but what you can do is you can find the artifacts in these process command line arguments, and then you can search for other things and confirm if they made it to your environment. So you can check network logs and see if this domain was reached out to, or DNS logs to see if it actually made it. Or you can say, well, let's look at the file create logs to see, did this file actually land in the directory that's listed in the script or the file, which gives you a lot of different pivot points to take this investigation. So it's not just, hey, we found it, we're done. You find the artifacts and you continue that investigation, but this just makes it easier.
And Lee, I guess you can compare that domain against, that the download domain against allowless as well to see if that's permitted. I know a lot of threat actors do try to stuff malicious code on Google Drive and things like that, which can make it a little bit trickier to disambiguate if that's malicious.
Absolutely. And another thing you can do is you can take a look at the process that's actually generating this. In this example, this is just our emulation and validation. So it's going to be as generic and benign as possible to validate the query, but you might start seeing different processes that are kicking off PowerShell that might be a little more suspicious.
I have a question about the Windows temporary directory. So if they stick a piece of malware in that temporary directory, will that survive a restart of the machine?
So most likely no, assuming that I could be making wrong assumptions, but normally what'll happen is once they get their payload in, they're not going to try and just leave it there. Now, if all they wanted was that initial access and they're not worried about surviving a restart and just getting blown away, cool. But normally what happens is after they get the payload in the environment, what they're trying or what their next goal is persistence. So they're going to probably create a scheduled task. Start service. There's a million different things they can do to make sure that payload it survived, so they can rename it and put it somewhere else, like the user's public directory, or like I said, scheduled task, registry key modification, auto run kind of things. But yeah, hope that answered your question.
Yep, thank you.
All right. Well, thanks everyone for joining today's Happy Hunting video. In this episode, we broke down how adversaries are using PowerShell to download malicious scripts and payloads, in addition to the many legitimate administrative functionalities it contains, and showed how a behavior-based hunt can uncover the activity even when specific details change. The community hunt package we used, methods for downloading files with PowerShell, is linked in the description of this video. Try it out in your own environment, see what you find, and let us know what threats you want to see next. Till next time, happy hunting.